Today we're going to be talking about 8.4 and 8.5, which is showing that triangles are similar. It's going to look very close to what we did for triangles being congruent. Just a little bit of difference. So let's use our warm-up to find that difference. So what do we know about similar triangles or similar figures? We know that the angles are congruent, and we know that the sides are proportional. All right, so let's go through this. The first thing I want you to do is write the statement of proportionality. So for part A, statement of proportionality, you can go by the figure. I think it's easier to go based off of the similarity statement. So based off that similarity statement, we have BTW is similar to ETC. So what sides line up? We have BT over ET. So that would be our first statement. Now remember, if this first triangle is on top of that first fraction, then it has to stay on top of all of the fractions. So then I have TW over TC. And then my last one, do the first and last side, so BW over EC. So there's your proportionality statement. Okay, now the next part, we're going to find angle TEC. Well, what do we know about angle TEC? I made it orange over here. Angle TEC is going to be congruent to another angle in the big triangle. Okay, so if these are similar, this guy is going to be the same as this guy. We've got 79. You can find the third angle by subtracting from 180 if we needed to find angle C or W. Okay, last part. We're going to find ET and BE. Now, BE is just part of a side. It's not a full side, so we're actually going to ignore that for right now, and we're going to find ET first. So we're going to find this guy first, okay? So I'm going to put my small triangle on top. I'm going to put my big triangle on the bottom. So my small triangle is this little guy up here, TEC. Okay, the little guy I made blue. Okay, so what sides do we know? I know I have this 3, and that I see that as like a base, and that goes with the base of the big triangle. Remember, the big triangle is this guy, which would be 12. Then I have my side. Well, I don't know what ET is, so I'll fill it in with X, but I do know this entire side for the big triangle is 20. Remember, you are welcome to simplify fractions before you cross multiply, so if I do that, I'm going to be left with, I can pull a 3 out of 3 and 12 to get 1 over 4, and then cross multiply. 4 times x is 4x, 1 times 20, so equals 20. Divide each side by 4, and x equals 5. That means this guy right here, so ET, we found to be 5. If ET is 5 and this whole side is 20, what's left for BE? 15. Okay. All right, now let's look at to see how we can show that triangles are similar if we're not told that they're similar. So there's 3 theorems for that, and they're going to look very similar to the theorems for congruent. They're just going to work differently. The first one is AA, which is angle, angle. Angle, angle means if we have 2 triangles, I have one angle over here that's congruent to an angle over here. I have another angle in that first triangle congruent to another angle in the second triangle. So I have angle, angle here, and angle, angle here. So these 2 triangles would be similar. The next one is side, angle, side. Okay, side, angle, side, very similar to what we had for congruent. It's just a little different. So I do have an angle congruent to an angle, okay? And then I have, let's go ahead and label these A, B, C, L, M, N. Then I have to set up proportions because I have to have side, angle, side. So if this is my angle over here, I'm going to use these 2 sides that form that angle. Same with this, the 2 sides that form that angle. So I have side, angle, side, side, angle, side. Now we need to set up our proportions. So I have AC over LN equals, and then do the other side. So we have AB over LM, which would be the other side. So if these two are equal and we have the angle between them equal, then yes, they are similar by side, angle, side. The last one is side, side, side. Okay, side, side, side says if we have two triangles, PQR and ABC. If we have two triangles, I should be able to set up my three proportions and they should be equal. So if I have PQ over AB equals QR over BC equals PR over AC. If I can set up those three proportions and they're equal, then yes, they're similar by side, side, side. So let's practice that. So this first one, number one, I have three options. I'm going to write a similarity statement if they're similar, state why, and a scale factor if I can. So if I want to tell if they're similar or not, I'm going to list out my three options. So let's look at those. Well, do I know anything about the sides in these two triangles? No. So I can go ahead, there's no way I have side, side, side. There's no way I have side, angle, side. I don't know anything about the sides. Now let's look at the angles. Now be careful looking at the angles because sometimes you have to find that missing piece. Right now, 72 is congruent to 72, but 39 and 41 are not congruent. So I'm going to find the third angle in that first triangle by taking 180 minus 79, minus 72 minus 39 to find that missing angle. Because that's going to tell me if that third angle is going to be the same. And I got 69. Well, 39 and 69, neither one of those are 41. So are these two triangles congruent? No. Or similar, good grief. No, they're not similar. Why? Because two angles aren't the same as two other angles. Next one. For this one, I have angle, angle, side, angle, side, and side, side, side. Do I know something about two angles in each triangle? No, and I don't have any parallel lines, so I can't find the other angles, so that's out. No angle, angle. Do I have all three sides in each triangle? Nope, so that's out. I do have one angle in each triangle, and I have the two sides that form that angle. Now those are congruent marks, but if they're congruent, say this is 5 and this is 5 and this is 10 and this is 10, since they're equal. If I set up those ratios, 5 over 5 and 10 over 10, 5 over 5 simplifies to 1, 10 over 10 simplifies to 1. So even though they're congruent, it still works for similarity. So these would be, yes, by side, angle, side. So there's part A. Now I need my similarity statement. So triangle PMS is similar to triangle what? I'm going to delete these. All right, so P is here. It's between no marks and 1 mark. So no marks to 1 mark would be R. M is congruent to M, and that leaves N for the last one. I cannot make a scale factor because I don't have the side lengths for any of the sides. Okay, next one, number 3. All right, so we have angle, angle, side, angle, side, and side, side, side. Do I know anything about the angles in either triangle? Nope. So we can cross angle, angle off. Do I know one angle in each triangle? Nope. So it can't be side, side, or side, angle, side. So we're looking at side, side, side. So let's set this up. I'm going to put this triangle I'm making red on top, and then this triangle in pink on the bottom. So on top, we have, I'm going to do my smallest side, which is 18. My smallest side in the pink triangle would be 14. My middle side in the big triangle would be 20. My middle side in the pink triangle would be 15. My largest side in the big triangle would be 32. And my largest side in the pink triangle would be 24. Now you have two options. You can either simplify each of the fractions, or you can go ahead and just divide them to get decimals and compare those. So if I divide them, let's see what happens. So I'm going to take that first fraction, and we're going to do 18 divided by 14 to get 1.28. Then we're going to do 20 divided by 15 to get 1.33. and 32 divided by 24 to get 1.33. Are all three of those the same? No. So are these two triangles similar? No. Or you could have simplified the fraction. So if I do that, 18 and 14, I can pull a 2 out to get 9 over 7. 20 and 15, I can pull a 5 out to get 4 over 3. And 32 and 24, I can pull an 8 out to get 4 over 3. So you do end up with the same thing. Okay, next one. I have three options: angle, angle, side, angle, side, 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 side. Okay, do I know something about two angles in each triangle? Nope, so angle, angle's out. So I have two options for this one because I do have an angle in each triangle, so we could look at side, side, side. And I do have all three sides in each triangle, so you could look at side, angle, side, or side, side, side. All right, so let's do side, side, side first. No, let's do side, angle, side first. So here's 37. So I'm going to look at these two sides that make that 37. Here's 37. We're going to look at the two sides that make that angle. So the 37 and 37 are equal, so the angle is good. Now let's check the sides. So let's set up our proportions. The smaller side of the first triangle is 24. The smaller side of the second triangle would be 25. Nope, would be 20. The bigger side of that first triangle would be 30. The bigger side of the second triangle would be the 25. And remember, we're just looking at the sides that make angle 37. All right. Whoa. All right, so right now those don't look the same. Let's simplify them. So what can I pull out of 24 and 20? I can pull a 4 out. So 24 divided by 4 is 6. 20 divided by 4 is 5. Next one, 30 and 25. What can I pull out? I can pull a 5 out. 30 divided by 5 is 6. 25 divided by 5 is 5. Those are the same. So yes, we could say it's similar by side, 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 angle, side. Or we can go ahead and set up that third proportion, so the 18 over 15. And if I simplify that, 18 and 15, I can pull out a 3 to get another 6 over 5. All three of those are the same, so we can also say they're similar by side, side, side. So either one of those could have been answers. Okay, we have our similarity statement. So I have triangle RPQ is similar to triangle what? Okay, R is by the smallest and biggest side. So I go to the smallest and biggest side, and we have F. 37 is congruent to 37, so P goes with D, and then we have E left over. Your scale factor you've already found. That's this guy right here where you simplified the proportions. So our scale factor would be 6 over 5, or 6 to 5. Okay? Next one. Sometimes you're not going to be given numbers, but anytime you see parallel lines, we want to think transversal. So yes, this angle is congruent to itself. We also have this transversal and this transversal. From the transversal to the parallel line, transversal to the parallel line, we have corresponding angles which are congruent. So we have angle, angle, side, 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 side. Well, I don't have any numbers for the sides. I don't have any congruent marks, so I can't do side, side, side or side, angle, side. I do have two angles in each triangle. I have my little triangle right here, okay? And then I have my big triangle right here. And I have this angle congruent to itself, and then these two angles congruent. Or you could have done these two. So I do have yes by angle, angle. We cannot find the scale factor because we don't have any numbers, but we can write our congruency statement. So I have triangle, let's do the little guy, VZY is similar to triangle what? V goes with itself, Z goes with X, and Y goes with W. There you go. And then the last one, we have side, 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 angle, angle. So in this one, do I know anything about the sides? Nope. So I'm going to cross those out. We're looking at angle, angle. Well, this angle is congruent to this angle is congruent to this angle. So yes, Yes, by angle, angle. I can't do a scale factor, but I can do a similarity statement. And since these actually come out to be equilateral triangles, all of the angles are congruent, all of the sides are congruent. All right, now let's do a couple solving ones. We're just going to do 3. With the solving ones, when you're missing sides, you are setting up your proportions. If you're missing angles, you're setting angles equal to each other. So we're going to set up our proportions based off of the similarity statements. So if we look at this similarity statement on number 7, I'm going to set up my proportions. And I'm going to put this triangle that's on the top of the fraction, all the way through. So I'm going to start with 55. 55 is DL. So DL is right here. It would go with LM. Here's LM, so I put it over 132. Then I have EL, so 17x minus 3 over EL, first and last, goes with LN, which would be 156. From there, we can cross multiply. Remember, when you cross multiply, be very careful going this way because you need to multiply 132 to both of those terms. So I'm going to write it with the parentheses, and then we do the equal sign and go the other way. And now let's actually multiply. So we have this to distribute. So we have 132 times 17, which is 2,244 x, and then distribute it again. We have 132 times 3, which is minus 396. And then do your other side. We have 55 times 156, which is 8,580. And then we can add to both sides. That's gone. We're going to add the 396 to get 8,976. And then divide. And x comes out to be 4. There you go. Okay. Now sometimes the triangles are written together like this next one. So you do want to look at this as 2 triangles. We have our small triangle I'm going to make green. And then you have your big triangle that I'm going to highlight. I'm going to put the small triangle on top, the big triangle on the bottom. So my small triangle, I'm going to set up my sides. I'm going to start with this guy on top, so 21, and he would go with the 98. Then I have the right side, which is 12, and then the whole right side is 56. The left side is 18, and the whole left side would be 12x. Now you only need 2 fractions to cross multiply, so you can ignore one of these. So I'm just going to ignore the first one. And let's cross multiply the last one. So if I cross multiply that, I'm going to go this way first. So 12 times 12 is 144x. And then 56 times 18 is 1008. I'm going to take that 1008 and I'm going to divide it by 144 to get x equals 7. Okay, we're going to skip number 9 and do the last one. I wanted you to see one where you're solving for 2 side lengths. So with 2 side lengths, I'm going to put this first triangle on top, the second triangle on the bottom. So I'm going to start with 20. 20 is between 1 mark, and 2 marks, that guy. 1 mark to 2 marks would be 15. Then I'm going to do y. Y is between 1 mark to no marks. 1 mark to no marks would be 12. And then x is between no marks to 2 marks. So no marks to 2 marks would be 18. And then from there, you're going to take one fraction without a variable, 1 fraction with a variable, and cross multiply. So we have 20 over 15 equals y over 12. And then we're going to do the same for the other one. 1 fraction without a variable, and then use the fraction with our other variable. So we have 2 problems we're cross multiplying. I'm going to go ahead and simplify my fractions to make life easier. I'm going to pull a 5 out of top and bottom, so 4 over 3, and then cross multiply. I have 3y equals 48. Divide by 3, and y comes out to be 16. And then the other way, I can simplify 20 over 15 again by pulling a 5 out to get 4 over 3. Cross multiply. Divide by 3, and x comes out to be 24. So use those proportions. Remember, similar triangles, congruent angles,